So this is Physics 2211. My name is Chuck Eisenhauer, Section N. This is Lab 1. So first off, with Lab 1, we were supposed to record a video, so I picked a basketball and took a video with my phone. I tried to keep my phone as steady as possible, but the lighting is not necessarily the best lighting in the world. So for future labs, I will be doing better lighting. You'll notice my video doesn't start from the start. It actually starts over here in the middle. I tried to pick a time that was the most constant, like when the ball had the most constant velocity. So then you went through the whole steps and picked the center of the ball with a whole bunch of different points. And I guess the source of error in mine was, as you could see when I kind of picked those points, that they weren't necessarily straight up across the board. So human error kind of had a rough time picking the center of the ball, as well as the fact that the ball might not have necessarily rolled straight across or completely parallel to where my phone is recording the video. Regardless, we went over to the data table over here, and the time started at 0, and then the X position where that ball started was a little off center of where I put the axes, but I mean it was by 8,000, or not very far off, so it wasn't that big of a deal when it came to factoring it in. And if you look at this graph, you can also see that that Y position is kind of changing as well. So it's not necessarily perfectly straight. That's a big source of error. This was our starting position. This is the starting time, and we went and put that in the code. And the code is in VPython. And so I weighed the ball, or more or less, I looked up the weight of a normal basketball and used that as my weight. I put the initial X position, and for the position vector, I put the initial velocity that you calculated from the change in distance over the change in time, which ended up being 1.19, and the ball velocity vector, which was the initial vector, and then the time, initial time was 0. So I used a delta t of 1/100th as my change in time. When I looked back over at the data table from Tracker at my times, 1/100th seemed about a legitimate small number that would have been good for steps. And then you uncomputed this stuff, and you really just plugged everything back into the loop, and when it printed that CSV file. That CSV file got opened back up in, well, mine was Chrome, in Google as a Google document, and everything got pasted into this spreadsheet. This first experimental position is the same amount of data that's going to be in this model position, so they can get put side by side on that graph. And then that graph is shown here as the model versus experiment. All of the positions, when I was putting them in the code and when they were plotted on the graph, was in meters, and all the time was in seconds. As you can see, the model position, or what should have been the model position, was perfectly straight. The experimental position was not. It looks kind of similar to what the tracker graph was, but the model position is perfectly straight, because when we look at our code and run it and see that model, it doesn't have any outside forces acting on it. Whereas, so this is with a net force of 0, so it doesn't have any forces acting on it. There's no gravity, there's no friction, there's no anything. But when you go back and check the experimental position is taking into the fact that there was friction from the ground, there was air friction, and there was gravity that was slowing the ball down. So it's not necessarily a perfectly constant velocity, because the net force wasn't actually 0. Whereas in our code, when we calculate the net force here, we're assuming that there is no gravitational force acting on it, and that there's no friction acting on it. So yeah, that's why the graphs don't line up perfectly, and pretty much what we learned out of this is that Newton's second law isn't flawless, or at least it's not the same as the first. The first one doesn't necessarily imply Newton's second law. Newton's first law says that there's no other forces acting on it, so the final velocity is the initial velocity, whereas this one, we have friction, we have gravity that are affecting the force, and it's not necessarily traveling in a perfectly straight line. So That's why the graphs don't line up. And that's about it. Where did that go?